SciTechTalk from our foreign correspondent. United States, Florida, West Palm Beach. Victor, the technician. I'm talking with Victor Johnson now, and I have a couple of questions which he would like to answer, I hope. The first question I have for you, Victor, can you tell me what you did on the fiber to home technician, the FTTH as it is called? Is that correct?
Yeah, FTTH is just an abbreviation because fiber to the home is a mouthful to say every time you want to talk about the technology. Mm-hmm. Originally, I was an installer. I was the technician that brought service to the customer's house. When they would have an appointment to be home, I was the one who would set up all the equipment inside the house. I would verify the service. So let me begin by talking about how fiber optics is not as well dispersed here in America as a copper service. In other words, cable TV or telephone service is predominantly the major form of delivering internet and telephone and video services to the house right now. Within the last 10 years, there's been great strides in improving that, and one of the key companies that is improving that is Verizon. And so I was a technician for them, and I did all the installations from the what we call as the fiber hub to the terminal to the house.
Okay.
And so what I'm going to discuss is the different areas where a technician would hook up the service, so to speak, and I'm going to try to go into more detail as possible.
Okay.
So I'm pretty much the Verizon setup was based on the ITU G987 standard. ITU stands for the International Telecommunication Union. They pretty much are in charge of standardizing the telecom industry. Nothing worse than a manufacturer having to create different products that won't integrate with other areas. So they pretty much create a standard, just like any other industry, whether it's the computer industry, automotive industry. They need a standardization. So they've created this model that they are using for what we call the GPON.
The GPON.
Now, G stands for G like the gigabit passive optical network.
Okay.
So the reason why they call it a passive network is because from the central office to the customer's house, there's no need for any type of electrical amplification. It's a passive network.
Okay.
So in order to give you a better understanding how a fiber network starts, picture in your imagination a central office where the main signal begins, that the provider takes the signal and broadcasts it to the customer.
Okay.
So what you have at the central office is a building. A lot of times they'll have some backup generators in case of maybe an electrical outage. You might see some huge antennas where they're receiving video signal, possibly maybe a wireless signal. This is where they integrate with the main internet, the main backbone internet, the main telephone lines that come in. The video signal is brought in a lot of times through satellite dish. So what you would see, and I did not work inside the central office, but I have a general understanding of how the fiber network is established. What you would see here at the central office is an OLT. What they do is they have what you call PON cards. They're little cards that allow the system to be expanded. They have multiplexers. They have a unique piece of equipment that is called an EDFA. What that is erbium-doped fiber amplifier. What that does, erbium is an element that, when activated, is a natural amplifier. So what this does is allows the when the laser and the light signal hits this, it allows the frequency of the fiber to increase naturally. So, generally speaking, the companies that provide fiber will have your voice, which is your telephone service, your video, which is your television service, and your internet. So what they have to do is they have to combine these three services on one fiber strand to the customer's house. So what they use is multiplexing. They have a piece of equipment at the central office. Most of them, which when I was working, were using a standard called dense wave division multiplexing. And that allows them to integrate all of the information without getting too technical onto the fiber optic signal. Now, the frequencies which these different services are broadcasted on the nanometer scale, your voice and your internet, because you require two-way communication on those, has to have a return path. In other words, you cannot have internet and just go one way. You have to have return path. So generally speaking, your transmit level from the central office would be 1440 nanometers, and your return path would be 1310 nanometers for your voice and data. Your video signal, which is the most amount of bandwidth, would be on the 1550. And so what you have in the central office is they take the video signal, they take the internet backbone, I believe they use the Juniper card, and they take the telephone service, and they use the main frames there, and they combine them, and they transmit them to the next step, which is the fiber distribution hub. So pretty much what, from the central office, just to keep it simple, they take the three forms of service and they combine them and they send them to the fiber distribution hub. Okay, and so that's the type of technology we see at the central office, and we mentioned why we call it PON, the passive optical network, is because compared to, say, like a cable where you would see amplifiers along, if you drive down the highway and you look up, you would see these little boxes where they would have to amplify the signal down the highway. The reason why we call it PON is because it's passive, no need for amplification until it gets to the house.
Okay, so it's a passive it's a passive component, but there are components to amplify the signal.
Yes, in the central office, the EDFA, there are it's amplified, and the only other time where you see power needed is at the customer's house. So between the central office and the house, no electrical equipment is needed. Okay. Which is a huge cost factor when you compare it to other systems.
I can imagine that, yeah. Can you describe the fiber cable itself, and are there different types?
Yes. Well, from the central office, what you're going to have is, generally speaking, a ribbon cable, which will have, it's more than one cable. It can have anywhere between 12 to a few hundred running to a different area. The next step would be the fiber distribution hub. And so from the central office, let's say they run to right outside where your neighborhood is. Let's say you live in a community. Let's say you have about 3,000 houses in your community. What you'll see is a little box right outside that community. And that is what you call the fiber distribution hub. And this ribbon cable will go into that hub. Within the hub, you will have these splitters. Now, in my experience, you could take a fiber line, and one line will split normally between 24 and 32 homes. And so I believe under GPON, you're looking at 2.5 gigabits split up into 24 homes, which is quite a bit of bandwidth. If you do the math, 24, 32 homes. But that cable, generally you have your main big cables. The cables that you see outside are very well insulated. They have Kevlar, what they look like little rods outside to prevent from shattering the glass. Pretty much what fiber optic is just small sizes, the size of a hair of glass, and inside the cable you have light that is reflected, and the fiber optic can come in single mode or multi-mode. Single mode is good for longer distance. Corning makes quite a bit of the fiber cable in America. Usually the system that I'm working with is light reflected at an 8-degree angle.
Okay.
Now, something I remember from physics, I believe the angle of incidence equals the angle of reflection.
Yeah, yeah.
So picture pulses of light bouncing around inside that fiber at an 8-degree. If you ever look at the end of the fiber cable, it's not actually quite straight. It's angled polished connectors. That's why they call them APC connectors. They're transmitting light at an 8-degree angle so that it's bouncing along the sides of that fiber.
Okay.
So, you have different forms of fiber optic cable. The multi-mode has a wider nanometer center. Single mode has a smaller nanometer center. And generally what you would see on the longer distances would be your single mode cable. Multi-mode generally tends to be smaller jumpers, shorter distances. But from what my experience was, we were using single mode fiber. Okay. So the fiber would get to a distribution hub, and it would be split into 24 or 32. So what you would take is that connector and connect it to a port inside that fiber hub that would match the port that runs to the terminal right outside the customer's house. And so when you're thinking about fiber, you want to think of it more like plumbing, because it doesn't conduct electricity. It's pretty much pulsing light. And so you want the fiber tube, so to speak, to be continuous all the way to the house. Now, there were times where we would have the what we call the cross connects mislabeled. So what we would end up taking is a red laser, and we would go to where the customer's terminal was and shine this red laser light, and you would see a red pulsing light, almost like one of those red lasers you would see a teacher using on a board, a red pointer. So you would go back to the fiber hub, and you would look at all the ports, and you would physically see that red light, so you would know exactly which port to connect to.
Okay, I can imagine that.
Normally, yeah. So in a well-constructed area, normally the cross-connect numbers would be well documented. But as you know, with any technology, when they use contractors and such, mistakes are made on the actual the schematics and such. So. I'm more of a technician rather than a teacher, so I hope that I'm communicating properly and I'm conveying the technology a little bit better so people can understand it. And the reason why I'm so passionate about this is because eventually you're going to see most copper-based systems disappear in the next 10 years.
Yeah, I think so too. Yeah, I think so too. That is a reasonable assumption, I think. You talked about multi-mode and single-mode fiber optic cables. And if I understood it right, then the single-mode optical cable can span longer distances. Is that correct?
Yes. Something in the internal diameter of the actual fiber. I'm not sure if anybody listening to the show has actually ever handled fiber cable, but fiber is consisted of a core. It's, like I said, it's the size of the hair. A single mode, the core of that fiber would be more or less 9 nanometers. A multi-mode fiber would probably be around the 50 nanometers. So when you incorporate the cladding is what you have right outside of that fiber. Including the cladding would be 62.5 nanometers for multi-mode and about 9 nanometers for the single mode.
Okay, the cladding.
So it's the actual internal.
The cladding is.
The cladding, I believe, is what goes right outside the fiber. I believe it helps it in its reflective abilities. Right outside the cladding, you have the coating, and then you have a buffer. Yeah.
Okay, the cladding is not the outside of the cable. That's not the cladding. No. There's many different layers that you see in the actual when you cut open a fiber. Yeah.
You have many different protective layers because. Actually, this is so sensitive. It's like glass. If you didn't have a certain amount of protection, even the large boom of a lightning storm can actually damage a fiber cable. An explosion of lightning would. So you need many different layers to protect that sensitive. Center of the fiber optic cable.
Yeah. Okay. I think that the bending of the cable is also a problem. It can't bend too much, of course.
Yes. In fiber to the home applications, you use the reflection and refraction terms. Mm-hmm. You want reflection, you don't want refraction. If you bend it, the way they taught us when handling the fiber in the ONT, which is I'll get to in a second, which is at the customer's house. Mm-hmm. Sometimes you have to wrap around excess fiber. They tell us to be on the safe side, try to keep the size of the rotating, the size of a softball, no smaller than a baseball. So maybe 3 inches or more in diameter. Now, the funny thing is when I was working apartment complexes where they had to get fiber into some sort of weird angles, you have to remember a lot of buildings were not built with fiber in them, so these have to be post-wired later. Corning came up with a fiber that actually can be bent pretty well and still maintain its transmission levels. So you're seeing a lot of plenum fiber and some of these fibers that are being developed by Corning. You could actually see a lot of that stuff on Corning's website.
Okay.
That can pretty much take a beating as far as bending.
Okay.
But generally speaking, you want to be mindful of that. Yeah.
Yeah. The two points with the fiber optic cable which I read about was bending can be a problem, and pulling, the pull strength, which isn't very great for fiber optic cables. Huh?
Yes. Fiber, one of the biggest problems it has is because it's sensitive. But you want to be careful not to snap the cable. So there are standards when it comes to pulling fiber through a conduit. But generally speaking, once it's there, once it's set up and tested, unless somebody goes into it and starts messing with it, maybe digging in the wrong place, they predict that the fiber will actually last longer than copper.
Okay.
So, everything is tested to a standard. You don't want to pull too hard. You don't want to bend it too much. And but yeah, you're absolutely right. It is very sensitive.
Yeah. I want to return once again to the single mode and multi-mode. Do we know why the single mode can be used over a longer distance than the multi-mode cable?
There are principles of refraction. In multi-mode, because of the larger core, you're going to be seeing more refraction on a longer distance, whereas on a shorter distance, you can allow much more transmission on a multi-mode. So that's why you would normally see on a local area network sort of a multi-mode being used. But if you go at a distance, you could see a single mode. I'm trying to read more specific on that.
It's
I'm looking at a web page right now.
Oh yeah.
But that's generally the principle is refraction. Distance and the size of the core is the way it reflects and refracts.
Yeah.
But like I said, I'm not a specialist on the actual specifics on that.
Now I can imagine it's a little bit a very specific question.
Well, let me just at the point of let me just read something I have in front of me.
Okay.
Multi-mode fiber optic cable has a large diametral core that allows multiple modes of light to propagate. Because of this, number of light reflections created as the light passes through the core increases, creating the ability for more data to pass through at a given time. Because of the high dispersion and attenuation rate, with this type of fiber, the quality of the signal is reduced over long distances. This application is typically used for short distances, data, and audio-video applications in local area networks. So it seems like the multi-mode is used for shorter distance. Single-mode fiber optic cable has a small diametrical core that allows only one mode of light to propagate. Because of this, the number of light reflections created as the light passes through the core decreases, lowering attenuation, which is bad, and creating the ability for signal to travel faster and further. This application is typically used in long-distance, higher bandwidth runs by telco companies and such.
Okay.
So single mode is smaller microns, which so in the reflective abilities, they use single mode.
Okay. That makes it a little bit clearer. have a next question, Victor, for you. How is fiber better than cable?
Well, one thing that people notice, I'm not sure how it is where you are. Say somebody who is further away from the central office, if they want to get traditional phone service, a lot of time they're declined. They're saying, we cannot bring service to you. Picture a farmer. He's out in the country. He has his cows. He's got his windmill out there. He's got his services. You'll see power go out there, but sometimes cable or telephone will say, hey, you're just too far away. It would cost us thousands of dollars to bring service to this one person. It's not cost effective to us. They probably won't admit that. They'll just say it's not available. But really what's going through their mind is, why would we spend $25,000 to bring service to somebody who will never recover that?
Yeah.
They'll look for it as a business standpoint. And that's just one person. So the thing with fiber is the dB loss, the decibel loss, you lose about 1 decibel per mile. If I'm not mistaken, with cable, just with the residential side, I believe you lose 3 dB per 100 feet.
Okay.
On an RG6 cable. So as you can see, the attenuation on a piece of copper, because of the technology and the science behind it, you're losing a lot of signal, so everything has to be amplified. And when it comes to services, when something is amplified, you not only are you raising the signal, you're also raising the noise level with it. So your signal to noise ratio on an amplified network is also raised. And when you have a high SNR level, you get a lot of lost packets on the internet. It means it has to retransmit it again. You're probably familiar with that, right?
Yeah, certainly.
So with a passive network such as fiber, you can deliver service further away to the customer's premise than you would a copper service, and you would have a lot less cost. So your economies of scale are greater the further out you are when you're comparing one technology to the other.
Oh, that's clear.
Now, if somebody's very close to the central office, it might be almost a similar cost to the provider.
Okay.
So, but also it's more secure. I don't know if you've ever watched a movie where a spy can actually go outside somebody's phone terminal. They could attach a butt set and listen in on a conversation.
Yeah, I saw that.
Yeah. Well, that would be very, very hard to do with a fiber network. There's no way to really cut into the fiber. You can't really. You would have to have some sort of fiber deconverter, reconverter to be able to listen in on a conversation. So it's much more secure as far as traffic standpoint.
Yeah.
And, there are much more advantages. And as Moore's Law continues, I believe that technology will get cheaper and faster over time. I believe fiber is going to be the way to go. So, much more secure, less interface. It can go further, and it's cheaper over time.
Yeah. I read something about the development of the fiber cable today, and that has made a lot of advance since maybe the last 10-20 years. It went up in the speed that it can deliver very, very much.
Oh, absolutely. Corning is one of the leading developers. There's a lot of companies out there that are developing fiber products. Now, you don't see computers now with any form of input that will actually take a fiber cable. I'll actually, in a minute, if you still have time, I will discuss the residential side, which to me is the most exciting part of it.
Okay.
Of the installation. But at the moment, you don't buy a laptop with a fiber Ethernet port.
No.
Although there have been a few, remote instances of those, but you plug an Ethernet cable into your computer, right?
Yeah.
So,
yeah. That must be possible with fiber also.
Yeah, eventually there are going to be a broad scale of devices that will take a fiber Ethernet port. There is a standard being developed.
Okay.
And that's going to be interesting to see. Like we talked about earlier, Google has chosen Kansas City in America as the city that they will provide service for. What Google right now is offering is 1 gigabit service per customer.
That's already 100 times more than the average American has, I think.
Yeah, so you could see why there was a huge. Some cities were willing to even change their name to Google. It was like a whole big thing of pick me, get me, we'd love it.
A lot of pretending.
And so it was so exciting during the process. But they've actually announced recently that they're going to actually do 4 cities now. Kansas City, a couple other rural areas. I think they announced Austin, Texas, which is a huge technological hotbed in America.
Okay.
And when you think about the new TVs that are out, that you saw maybe in CES recently, where they have high definition, which are multiple times the high definition of the 1080p that we have right now.
Okay.
The only problem with that is as of now, networks are still broadcasting at 1080i, 720p and 1080i.
Yeah.
Some satellite channels are broadcasting at 1080p. What do you make of that, where the content is less than the delivery system?
Yeah.
So,
yeah.
Well, that would mean the networks would have to start upgrading their systems, right?
Yeah.
Start delivering more content. So it's always better to have a fatter pipe, where you can handle more than what you're throwing at it. And believe it or not, a lot of people are actually streaming their television shows through, Hulu and I believe Amazon and Netflix. They've got a lot of streaming. Apple has their streaming stuff you can get. So it almost seems like if you have a fast enough internet, you could sort of pick and choose your own content.
Oh yeah,
and eventually save money.
Yeah.
So
there is a great market for fiber optic, certainly in the future with all kinds of services that arise. HD, I never heard of it even.
Yeah, super high definition.
Okay.
Where they're building TVs that can handle it, and they don't have the service coming in.
Okay.
And in my experience as an installer, sometimes you would see a worse picture on a high definition TV than you would on a smaller TV because they don't have enough pixels in the picture to fill in the screen. It would be grainy.
Oh,
in other words, if you saw a 480i picture on a nice flat screen TV, you're like, oh my goodness. You have all these different types of signal trying to fill in a 1080 picture when they're only 480.
Yeah.
Does that make any sense?
Yeah, I can imagine that. Yeah.
See what I'm saying? So.
Yeah. A question that I have, is there 3D TV in America?
Yes, the 3D TVs that we see are generally 240 megahertz. Mm-hmm. And when I've worked for Comcast, they have some on-demand, and I think Verizon Fios has some on-demand for 3D programming. But you have to have the actual TV and the glasses to be able to view it.
Oh yeah.
But It's 240 hertz, I believe, megahertz is what the televisions go that have to process the three-dimensional TV.
Okay, yeah. And do you know the most commonly used system? There is that side-by-side technique.
Yeah, I see a lot of the side-by-side, and once you put the glasses on or it changes. But yeah, I believe it's side-by-side. I could be wrong on that because I haven't done a lot in 3D, but generally when I was bringing up a test, when I've had a customer ask me, I would see some sort of test screen where it was side by side. But like I said, technology changes a lot, and it could be different now.
Yeah,
so
that's true.
Well, one last thing I want to talk about, which is, like I said, the most exciting part as an installer, is the residential side. Currently, right now, I'm using cable system. I'm using a compact system because you have to use what's in your area. And believe it or not, cable has made some great strides. Like I said, if you're close to where the central office is, you can get decent speeds. They've actually upgraded my system to 50 megabits per second download. Mm-hmm. So I'm one of the lucky ones. I live in a newer neighborhood. But somebody in the country, not as lucky. And so, like we said, the distances are a problem. But I want to continue talking about what you would see if you ordered fiber from a fiber-to-the-home provider. Mm-hmm. You schedule an appointment, and somebody comes to your house. So what is that situation like? Maybe you are in a situation where you have fiber available to you, whether it's that Google Fiber. Oh, we were talking about the TVs and how you can get more content, 3D content, higher definition through a fiber network, clearer picture.
Yeah.
So let's say you are sold, yes, this is what I want, give it to me, I want it now. So you call your company. Normally what they do is they will verify that the service is available in your area. If you are available in an area where it's upgraded, where they have the hubs and the terminals all laid out, where they have that the main cables all run to your area, they will approve you for an installation date. Before a technician will come to your house, somebody will either bury a line or hang it on the pole. You'll either have an underground service or an aerial service. So, yeah, you say, I want the service. You call your service provider and you say, I want the service. And what they would normally do is they would follow all the other utilities, however they're run currently. If it's underground, what you will have is an underground crew come and bury a fiber optic line from the terminal. Earlier we discussed how you would take a red laser and identify your port at the terminal. Normally these terminals, you can have maybe 4 to 6 ports right on the sidewalk, right in front of your house. And they're pre-connectorized. The fiber that I was used to using is the fiber optic cable, and the connector are already pre-made. And what they would do is they would just wrap up the extra slack. They would have pre-made sizes, say 100 feet, 150 feet, 200 feet. And if they had to splice a connector to it, they can do that. But normally they're pre-connectorized. So you would get a line buried from the terminal underground, under your grass, to the outside of your house, normally close to where your power meter is. Normally you would have cable TV services, or you would have your telephone service there. And so before your appointment, if it was underground or in the air, somebody would have that line already pre-connected. And what you would see is a line sticking out of the ground. And as a technician, you would take that line, put it in a protective conduit. You would mount a box. Now, this is the key piece of equipment here. It's called an optical network terminal. We say ONT for short because that's a mouthful. So what you would normally do is take this conduit, go into the fiber box. You always want to protect that fiber in case somebody comes along who does your yard. They have a weed whacker. They may accidentally hit that fiber, so you always want to have it protected. And you would run the excess fiber into that box. There's a place where you could just wrap the extra fiber. And the head of that fiber you could actually screw into the port. And the ONT on the left side would have an input where you would put that in. And you would drill a hole inside the customer's house and provide a power source. You would put a battery backup unit. And normally, you would be close to the garage, so that would be placed inside where the garage is. Now, once you provide the fiber there and it's powered up, you normally would have a coax cable output for your video and your internet. You would also have an Ethernet port, which you could also use for internet. And you would have 2 to 4 telephone line ports. So the fiber will come all the way to your house. It would convert from fiber signal into regular signal that you could use with your current wiring, copper service. And so it would take that signal, RF signal, and convert it back and send it back to the central office for your phone and internet. Some people may say, well, doesn't this degrade the signal? Well, when you're talking about a few hundred feet from outside of your house to your device, no, there's not an issue there. I've done speed tests for commercial installs, and currently right now Verizon's actually offering 300 megabits, not as good as the Google, but you can get pretty good speeds even though it's down converted to copper within your house. That short distance does not make a difference. So pretty much you take the coax output and you use the existing wiring in your house and go to your cable splitters, a router, and that's how the services are provided to the house. Now, I can go into more detail, but it's pretty much the same way a cable system operates once you get to the house. Is you can split your cable lines, you check your decibel levels, make sure you don't have too much loss, your signal-to-noise ratio, things of that nature. Then you set up a wireless router, and you pretty much just go from there. Standard residential installation, just like before. But the speeds are much, much higher.
Does it make any difference if you have an underground cable or an aerial cable?
Question whether going underground or aerial makes a difference? No, it does not. The fiber is pretty much the same fiber. It's got the same protection. Rain and water do not have an issue on fiber because it's got that protection. Underground, same thing, unless you have some sort of external, like somebody's digging in the yard, that can hurt it. Sometimes you get squirrels on the lines, they can chew on it. But no difference between going in the air or underground. Generally, you want to be as aesthetically pleasing to the area. You don't want to have aerial lines when everything's going underground. You want to follow your existing utilities. Make it look nice. More for cosmetic differences.
Okay.
So yeah. There are a lot more details, but they're generally speaking, fiber is the best way to go. As far as I know, because of the bandwidth use, when it comes to fiber to the home, even though you are sharing the splitter, the 24 or 32 port splitter you are on, generally the fiber companies do not have a problem of you using as much as you want. There's actually a doubt of whether or not you can possibly use the full bandwidth that you are given, although some people have been known to try by downloading huge amounts of files, picturing also a business that does a lot of transmission. But generally speaking, I do not know of any company that offers fiber that puts limits on your fiber use, unlike a copper service or a cell phone company or a cable company. But generally speaking, because fiber can carry so much signal, it doesn't degrade the signal for your neighbors or other subscribers, so it's not an issue for the provider. A lot of the reasons why some cities are chosen is whether or not the cities can grant access to the service. I don't know why Google chose Kansas City, but I know when I was working with Verizon is sometimes it's the communities and municipalities, how much of a hard time are they going to give them by bringing competition in? For example, Time Warner was seen to be concerned about the fiber because when it was announced, they hired a whole bunch of people to upgrade the system, make sure that everything was running in tip-top shape so that they don't lose too many customers. But normally speaking, I guess the decision is made on how easily it would be to bypass a lot of the laws and the restrictions on new competition in an area. I'm speaking only out of opinion here, not out of fact. But I think if I was running a system, I would ask myself, is this an area where people would buy my service? And they look at the users. So I would definitely not start with a city that had a low use of internet. That would be silly on a business standpoint. But I'm guessing that there are some hurdles when it comes through opening up your infrastructure to a company that those are taken into consideration. So I do know that Austin, Texas is a huge city that deals with a lot of technology, and it would be well received. This is an exciting technology. It's a lot to absorb in, say, an hour time. That's why I try not to get too technical on some of the more specifics, because if you don't understand the general concept behind it, then I would just be confusing everybody. So we can actually, after all of this sinks in, we could possibly have a part 2 of this session, maybe get more specific, maybe do a little bit more research. But the key thing to remember is that communication is very important in our day and age. It's absolutely necessary at this point. I remember 10 years ago, or remember back when Windows 95 and 98, where you were using dial-up modems. And in 1998, I think when cable modems first came out, they were only transmitting at 1 megabit per second, but people were dancing in the streets. Not literally, but they were dancing, so happy to get 1 megabit, and now people complain about 1 megabit.
Yeah.
Well, I mean, I remember I had a 56K modem. I believe U.S. Robotics came up with. I spent $200.
Oh yeah.
For a 56K modem, an upgrade from my 33 baud, 14.4 baud modems.
Yeah. I can remember also that. Yeah.
So
a lot of
communication is important.
Mm-hmm. Yeah, communications.
Yes.
Yeah, you're right.
So a lot of students. I did work in Tallahassee, where the University of Florida is there, big university here in America. Had 50,000. It didn't have fiber, but I was hooking up their cable service, and one of the biggest comments I heard is, well, if you can't do the TV today, just make sure you get the internet, because we have to take our classes on the internet.
Oh, yeah.
More of the educational system uses the internet, so a world without a fast internet will pretty much shut everything down at this point.
Yeah, I think you're right. We're coming to depend on it so much, and a lot of applications are already there, but there are a lot of applications that just become possible when this bandwidth is there.
I would encourage your listeners or your website followers, if anybody's interested, has any questions, we could talk about this again. If it's something I don't know, we could find out. We could also look at different perspectives on how this affects different industries. More or less talked about the residential, but it also affects commercial businesses and universities and many other aspects of life. So we can talk about that on another time. So if you have any questions, email them in. We could talk about any problems you may have with your cable system. They can pose their questions to SciTechTalk@gmail.com. SciTechTalk, SciTechTalk @gmail.com. Like I said, I have done work as a cable technician, and I've worked for every major cable company in America, and I've done thousands of installs. So if you have a question, we could address them. We could put them all together and do another broadcast. But I thank you for the opportunity, for the chance to talk about this. It is interesting, and we could plan on another session in a few days and talk about it. So once again, my name is Victor, and I thank you for the opportunity. And I appreciate that. And thank you for the chance to, talk about something I'm excited about. Okay? Good day.
Thank you, Victor, for your first contribution to the new SciTechTalk broadcast, our foreign correspondent. Thank you, and hopefully till the next time. This was Victor the Technician talking about fiber optic networks.
All right, bud. Thank you very much, and goodbye. Have a wonderful weekend, and good night.
SciTechTalk from our foreign correspondent.